Let's see what are transfer waves and longitudinal waves. When we see that motion of a mechanical waves involves oscillation of constituent of the media. If the constituent of the media oscillate perpendicular to the direction of the propagation we call the wave as transfer wave. If they oscillate along the direction of wave propagation, we call the wave as longitudinal wave. In the figure 1.2, shown that the propagation of single pulse along a string resulting from a single up and down jerk. If the string is very long compared to the size of the pulse, the pulse will damp out before it reaches the other end, and the reflection from that end may be ignored. In the figure 1.3, here we see the figure 1.3. What it indicates is a periodic wave traveling along the structured string is an example of transfer waves. An element of the string in the region of the wave oscillate along its equilibrium position or perpendicular to the direction of propagation of wave. And we see the figure 1.4 that longitudinal waves are generated in a pipe filling with air by moving the piston up and down. A volume elementary of air oscillate in the direction parallel to the direction of propagation of wave. This is the best example for longitudinal wave, and this is the best example for transfer waves. If we continue the session, show that a similar situation, but this time the external agent give a continuous periodic up and down jerk to one end of the string. The resultant disturbance on the string is then a periodic wave. In either can the elementary of the string oscillate above the equilibrium mean position. As the pulse or wave passes through them, the oscillation are normal to the direction of the wave motion along the string, so that is an example of transfer wave. We can look at the wave in two ways. We can fix an instant of the time and picture of the wave in the separated. This will give us a shape of the wave as whole in space at a given instant. Another way is to fix a location, that is, fix our attention on the particular element of the strain and set it oscillate motion time. In the figure 1.4, describe the situation of longitudinal wave in the most similar examples of the propagation of the sound wave. Along a pipe is filled with air as a piston at one end. A single sudden push forward and backward, the piston will generate a pulse of compression, that is high density, and a rarefaction low density in the medium air. If we push the piston continuously and periodically, a period wave and propagation in air along the length of the pipe. This is clarity an example of longitudinal wave. The wave considering above the transfer longitudinal are traveling or propagating wave, since they travel from one part of the medium to another. The material medium as a whole does move. As already noted, a team of examples constituent motion of water as shown whole. In the water wave, it is disturbance that move, not waste a whole. Likewise, a wind motion of air as whole should not be confused with the sound waves, which is a propagation of disturbance in pressure density in air without the motion of air medium as a whole.